The binary number system is a base 2 number system consisting of only the digits 1 and 0. In the base 10 decimal system, each place value is a power of 10. Similarly, in the binary number system, each place value is a power of 2. The first place value is 2 to the power of 0. The second is 2 to the power of 1. Next is 2 to the 2, 2 to the 3, and so on. The binary number system can be quite confusing at first, but after you get the hang of it, it's actually very simple. Let's try converting the decimal number 37 to binary. I will be working from left to right. First, I think, how many times does 32 go into 37? Once. 37 minus 32 leaves us with 5. How many times does 16 go into 5? 0. 8, 0, 4. 4 goes into 5 once. That leaves us with 1. 2 goes into 1 0 times, but 1 goes into 1 perfectly. Now we have the number 1, 0, 0, 1, 0, 1. Now let's try converting binary to decimal. I'll pick a random number, 110, 110. This means I have 132, 116, 14, and 12. All I have to do now is add them together. 32 plus 16 plus 4 plus 2 equals 54. Therefore, 110, 110 in binary is equal to the number 54 in decimal. The modern binary number system was officially discovered in the 17th century by a German mathematician named Gottfried Wilhelm Leibniz, well known for being a co-inventor of calculus. Despite that, the binary number system was known far before Leibniz discovered it. The origin of the binary number system can be traced far back to what we call the Book of Changes. The Book of Changes is one of the oldest books in Chinese history. After discovering that nature is a binary phenomena, a never-ending interaction between mutually dependent opposites, for example growth and decay, advancing and retreating, yin and yang, and so on, the ancient Chinese invented the binary code. They stored all this information in the form of trigrams and hexagrams inside the Book of Changes, also known as the I Ching. For thousands of years, the Book of Changes has functioned as a philosophical handbook of the universe, a guide to living an ethical life, a manual for rulers, and an oracle of one's own personal state and future. The ancient Chinese would consult the Book of Changes before making important judgments, weighing a series of binary options. Gottfried Leibniz announced his creation of the binary code in a paper published in 1789. Sometime after, he received pictures of the Chinese trigrams and hexagrams in the Book of Changes from a Jesuit in Beijing. Seeing this gave Leibniz the push he needed to continue his work with binary numbers. Seeing the Book of Changes gave him proof that his work was valid and had meaning. Leibniz released a second paper attributing the Chinese to developing the first form of binary code 24 years later. I believe this is a prime example of how culture and math relate. All cultures are different. Different cultures have different views, morals, ways of life, and ways of learning math. The Egyptians have the Eye of Horus. The Chinese have the Book of Changes. And no other culture came up with the same thing they did. But through trade and sharing of knowledge with other cultures, we get to expand our knowledge and widen our views to create something new. And that's beautiful. Ancient Chinese used their form of the binary system as a set of morals, a guidebook to life. In comparison, we use binary numbers for a much different reason, for our computers. Computers control and store all of its data, including numbers, words, films, pictures, and music using the binary number system. In our modern world, where technology is extremely important to us, binary numbers are very relevant. To be honest, I didn't put much thought into picking a topic for my project. I chose the binary number system as my concept because the idea of exploring number systems other than our usual decimal system intrigued me. As I dug deeper into my research of the history of binary numbers and how Chinese culture relates to it, I couldn't put my phone down. I find the Book of Changes extremely interesting, and I had plenty of fun researching it. I hope everyone enjoyed watching this presentation just as much as I enjoyed creating it.